right, we were talking about question 11, right? You have two data set A, set B, and set A consists of data points like 1, 2, 3, 4, 5, 6. Set B consists of 2, 3, 3, 4, 4, 5, right? Um, and then we need to be able to compare the means, compare the standard deviation. And the mean is simple. The mean is just calculating the average. Right? You add up all the data point, divided by the number of data point, which is 6. You calculate the mean. Now, how about the standard deviation? So let me show you what you need to do to calculate the standard deviation, or like what's happening behind the formula. What's happening? So I'm doing this only for set A. To give you an example. This is x of I. This is the list of data point 1, 2, 3, 4, 5, 6. Right? That's what the first column refers to. 1, 2, 3, 4, 5, 6. Right? The list of 6 data points. And then the next column, x of I minus mu. Mu is the mean of set A. I mean, and then x of I minus mu. So that means we take the 1 minus the mean of set A, 3.5, and enter the result in this column. 1 minus 3.5, which is negative 2.5, right? 2 minus 3.5, negative 1.5. Right? 3 minus 3.5, that's negative 0.5. And then 4 minus 3.5 is positive 0.5. 5 minus 3.5 is positive 1.3. 6 minus 3.5 is 2.5, positive 2.5. So this gives us the second column, which is the data point minus the mean, right? Now, and then we need to square it. The third column is x sub I, the data point minus the mean, and then square the whole thing. So negative 2.5 square is 6.25. Negative 1.5 square is 2.25. Negative 0.5 square that is 0.25, and so on and so forth, right? So this 2.25 is 1.5 square. This 6.25 is 2.5 square. So you have the third column. Now you want to add them all up. Right? This is a summation of x of I minus mu squared. So this is the sum of the third column here. And after we sum them up, the sum of this third column is 17.5. 17.5. Now, n refers to the number of data points in the data set. And in this case, set A has 1, 2, 3, 4, 5, 6 data points. So n is 6. N is 6. So the formula for standard deviation is you take this one, you take the sum of the third column, which is this entire value here, like 17.5. You divide that by n, in this case, which is 6. And then you take the square root of that. That is the standard deviation of A, which gives us 1.708. Right? So now n is 6. So this how we got this 1.708 is by 17.5 divided by 6 and take the square root of that, and this is the value that we get. Now you can do this similar thing for set B. Right? You can create another table. Now, of course, the value of xi will change. Instead of 1, 2, 3, 4, 5, 6, you are now going to have 2, 3, 3, 4, 4, 5. Right? 2, right? And then create the second column, xi minus mu, right? And then the mu in this case, well, will still be 3.5. It happens that the mean for set B is 3.5 also. And then you redo it, calculate the subtraction, carry out the subtraction, calculate the difference. After you have done the difference, square that, sum it, divided by n, which is 6 once more. take the square root, you're going to have this standard deviation of b. It turns out to be 0.957. So that's how you calculate the standard deviation. This is the formula. This is what goes in behind the formula. Now the formula you have, like, this is the Math is Fun website standard deviation. This is the formula. Notice that x sub I minus mu square summation, or like, what is this? This is what I have in the third column here. This is what I have in the third column, right? Right here. And then divided by n, times, they use times 1 over n, right? This is divided by n, which I have stated right here, divided by n. And then at the end, take the square root of the whole thing. So I'm using this formula, which is the population standard deviation. Now, for the purpose of SAT, you do not have to worry about the sample standard deviation, like that formula n-1. You do not need to worry about this for the moment. Maybe you take like some higher level statistic course, like AP statistics, then you will need to worry about like when we use that n-1. But for the moment, you just stick with this population standard deviation, then we're good, right? So this is what's behind those formula. Now, it's important to understand what's behind the formula. But when you're actually doing the test, you use a handheld, punch in the key to use the standard deviation key. You obviously won't have time to set up this table and add them up and calculate standard deviation this way. Right? When I first did it, this 1.708 come from a calculator. Right? But it's good for understanding. All right, hope that helps.